So now we're going to look at how we can compute the correlation coefficient with the carbon dioxide and CO2 emissions datasets from earlier. We're going to be working with these a lot for this chapter because a lot of these take the same sort of calculator inputs going in the same sort of directions, and it just makes more sense to stick with these consistently. But for this, there are actually a couple ways we can go about it. There's one that involves doing something a bit specific and turning on a special computation in the calculator to get it, and that's what I'll do first, and then I'll show a different way we can do this that involves a special computation that actually does just about everything we need in this chapter. So first, we're going to go in here and we have to make sure that our data set's in. But since we're using this one a lot, I'm going to start with it in here, and I'm not going to take it out for the next few videos where I'm working on this stuff, actually, because it just needs to stay in here anyway. But once these are all in there, we're going to go into the mode setting. It's a different place for us. And we're going to go down, and what we're going to do is turn on these things called stat diagnostics. That basically allows us to run some special computations in here once that's on. And hey, now we get a timestamp on this. Isn't that nice? You know exactly when I made this video. But anyway, from here, we're going to go into our stats menu, and we're going to go into our computations where we can either use option 4, linreg ax plus b, or linreg a plus bx. And I'll talk more about these guys in a later section when we're talking about regression. They actually do functionally the same thing, except they switch the names around for A and B, but don't worry about that too much right now. I'll pick option 4, where we're running on the X list is list 1, the Y list is list 2. We don't have a frequency list. We still don't have any frequency lists. And then if we want to get this thing called a regression equation, which we'll talk more about in 9.2, we can store that using the variables, but I'll save that for later. And we calculate. Where for here, when we run that calculation, instead of going through this mess of tables and this, oh boy, mess of manipulations with sums, we just get that our value for R here is about 0.874. And you'd have to do a lot of calculator computations anyway to get that, so this is much more efficient. That said, it's not the only way we can get that value R, which does indicate a strong positive linear correlation. That is our intuition from looking at that scatter plot from earlier. Seemed pretty good. The other way we can go about this is we go to stat, tests, and I'm going to scroll up here because the one we want is way at the bottom. This is what we're going to be seeing next, a thing called the linreg t-test, linear regression t-test, which is specifically for testing the usefulness of correlation coefficients. And in here, we're going to put list 1, list 2, frequencies 1, and we're going to ignore that thing that it asks about with beta and rho, because that's if we actually want to do a test. We don't really care about testing here, though. So we're not actually testing, we're just using this because it gives us a whole bunch of important values. It gives us a value A and B, those are things we're going to have to worry about in 9.2, as well as something S that we're going to see in 9.3, but for us, we get the value R just as well from this. And as I said, the linreg t-test computation is probably where you're going to live for most of this chapter. I'd really advise learning how to do it with this one, because it gets us everything we need, but you have to be a little bit subtle about what you're asking it to do. Anyway, this is really our workhorse, so this is what I'd recommend. It just takes a bit of thought to know how to get what we want from it, but in either case, we get our value R.